Before we go into completing the square, let's warm up with a nice simple quadratic. X minus 4 squared is equal to 5. And let's say we want to solve that. When we say we want to solve it, that means that we want to know the values of x which will make this statement true, which will make the left-hand side of the equation x minus 4 squared be equal to 5. Another way of expressing that is we could move the 5 to the other side. We could subtract 5 from both sides of the equation and end up with x minus 4 squared minus 5 is equal to 0. You could say that we're looking for the values of x which will make the whole equation, if it's all on one side of the equal sign, be equal to 0. Another and even more interesting way of expressing the equation would be to say f at x is equal to x minus 4 squared minus 5. And this form of the equation lets us ask, well, what is this graph going to look like? What is this equation going to give us as its output for any value of x we decide to use? Well, we're going to come back to this one since this is the really exciting form of it. But for the time being, let's start by solving the equation as it is. This side is squared, this side isn't. We want to find out what x is worth in this equation. So we want to get x all by itself. So the first thing we're going to do is we're going to get rid of the square. Using PEMDAS, please excuse my dear Aunt Sally, we know first we're looking at the parenthesis. There's nothing we can do to simplify the content of this parenthesis at this point. Then comes exponents. Yes, we do want to get rid of the exponent. So let's take the square root of both sides. Now we've got x minus 4 squared, square rooted, is equal to the square root of 5. Now let's actually perform the square rooting operation. Let's root it out. And now we've got x minus 4 is equal to the square root of 5, but now it's plus or minus the square root of 5. And the reason we have to do this is that we don't know yet what the values of x are that are going to make this true. The x minus 4 up here is squared. So the content of the expression up here, the x minus 4, regardless of whether it's positive or negative, the value of the parenthesis after we subtract 4 from whatever x is, we're going to square it. So it's going to end up positive since we don't know what the outcome of subtracting 4 of x is going to be. To deal with the ambiguity of x minus 4, that it could be a positive or a negative outcome, we won't be able to tell after we square it. We have to take account of both of those possibilities by when we remove the squaring by square rooting this side of the equation, we add a plus or minus sign on the other side. Now, we've got x minus 4 is equal to plus or minus the square root of 5, and if we add 4 to both sides, on this side the plus 4 and the negative 4 cancel out, so we've got x is equal to, on the one hand, 4 plus the square root of 5, on the other hand, 4 minus the square root of 5. And both of these values will make this equation true, and we'll make this equation true as well. Let's see how that works. If we substitute 4 plus the square root of 5 for the x, then we've got 4 plus the square root of 5 minus 4 squared minus 5 equals 0. The 4 and the minus 4 cancel each other out. Now we've got the square root of 5 squared minus 5 equals 0, and of course the square root of 5 squared is just 5, and 5 minus 5 equals 0. So this is absolutely true. Let's try the other one of our answers. If we put in for the x 4 minus the square root of 5 minus 4 squared minus 5 is equal to 0, Well, once again, the 4 and the negative 4 would take care of one another. Now we've got negative the square root of 5 squared minus 5 is equal to 0. When we square this, we're going to be multiplying a negative by a negative, so the negative becomes a positive. And when we square the square root of 5, once again we get a plain old 5, and 5 minus 5 is indeed 0. So we know that these two are the correct answers. Now let's have a look at the function form of the equation, the one which shows us everything this equation can do, what it's going to produce for every value of x. Here we were only concerned with the values of x, which when in this form would make the equation equal to 0. Now let's see what happens in every single situation that's possible. If I were to put this function into a calculator, I would get a very nice graph of it from which we could tell all sorts of things, but I don't really need a graphing calculator for this equation. I can tell you right now that the graph is going to look like this. And what's more, I can tell you that these 2 points are going to be, well, this point here is going to be, the x value is going to be 4 plus the square root of 5, and the y value is going to be 0. That's this point. And as for this point, the x value is going to be 4 minus the square root of 5, and the y value is going to be 0. And the way I know that is, in our equation, we figured that x minus 4 squared minus 5 was equal to 0 at these values. So when we put in this value for x into the equation, the y output is going to be 0. So that's how I know that when x is equal to 4 minus the square root of 5, the y height is going to be 0. Our answers were the x coordinates at which the y value, the y height, is going to be equal to 0. Furthermore, I can tell you that this point over here is going to be 0, 11. And the way I know that is, if I took my equation here and I said, all right, let's make x equal to 0. Before we were looking at values which would make the y equal to 0, but now let's say we want x to be equal to 0. All right, so f at 0 is equal to, substituting now a 0 for the x, 0 minus 4 squared minus 5. And 0 minus 4 squared is just minus 4 squared minus 5. And minus 4 squared, well, squaring a negative makes it positive. And 4 squared is 16, so we've got 16 minus 5, which is equal to 11. So when x is equal to 0, y is equal to 11, and here we are at point 0 on the x-axis. And we know at this point the y height is 11. So I know that my graph is going to go through the y-axis at 0, 11. The last point that I'm going to deal with right now is this one. And I know that's going to be point 4, negative 5. The x value is going to be 4, and the y value is going to be negative 5. How do I know that? This is a little bit more complicated, but a lot more interesting. If I had a plain old x squared, the graph of this would look like this. Yes, it would be one of our happy graphs, a going up on both sides smiling parabola. Now, if I were to graph x minus 4 squared, it would be the same graph, but the vertex would have shifted over 4. It would now be 4, 0, where the graph touches down on the x-axis. Now usually when they tell people how to use the information in this equation here, they tell you, well, that tells you have to move against the sign, which is kind of sort of handy, but it isn't really all that accurate. Let's go back to the x squared. This is the normative position for the simplest possible quadratic equation, just a plain old x squared. And at this point where it's x squared, it touches down at 0, 0, right on the origin. That's the normative touchdown point for the simplest possible parabola, the simplest possible quadratic. Now, its touchdown point, the point where it has no y height, is going to be the point which makes the outcome of this equation equal to 0. So if we made it into a 4 minus 4 squared, if we substituted a 4 for the x, we would have something which was equal to 0. So the y height would be equal to 0. So its touchdown point would be right here at positive 4. Now, we are in fact moving, it looks like we're moving against the sign, but the best way to really understand what's going on is we're in an unimproved parabolic graph where the x is modified in this way. We want to know, okay, what do we have to do to counteract what's going on in here so it'll have a y height of 0. Now, if we take our basic graph, we took an x squared, which would have looked like this. We then subtracted 4 from it, which moved its touchdown point over a little bit. Now we're going to subtract a 5 from it. And that simply takes the entire operation and moves it down 5 points to -5. So this part of the function, outside of this whole business involving x, the plain old number on the end lets you know how the y height has been modified. And thus we have 4, -5 as the point where the vertex touches down.